because they're not waiting on Mason to put one in. Okay. Today, if you look over your practice guide, starting in 2 pages, I'll hand out the stapler here in a second. In fact, we'll just start it going around right now. So you can staple it, sorry. All right. Name on it first. We'll be collecting these on the day we take tests. Test for us is Wednesday. So we'll kind of play by ear. Let's flip through just so you can get a look. I'm going to just scan through. I'm going to flip through this pretty quick so you can kind of watch up here if you don't want to. I just want to make sure you get kind of a sense for how big this thing is. There's not a lot of problems. It's just it takes time. Like number one, you have to graph. You're only graphing 7 points. You will not, and maybe you need to write a note on this, number one, we will not be drawing a line that connects them. The reason being, so write that down right now, number one, do not draw the line that connects your points. The reason being is that you're only drawing 7 coordinates. We're not drawing all of them. A line connecting all the dots means you're drawing every coordinate that, that can contain. We're only drawing 7. It's just to give you a rough idea like where the graph is going. We're going to be setting up a table and all that good stuff. So make sure that you are, we'll get back to this one here in a second, but make sure you are doing a table and you're actually going to graph those coordinates. It will be some type of either linear or curve, but it'll be something easy enough where it shouldn't take you very long to actually calculate. Moving on to the next ones, number 2, you're using this table. I will provide you a table from my graphing calculator, and then you're going to have to figure out the equation that goes with it. And depending on which function I'm picking, y1, y2, we'll talk about that here in a second. Then I'll ask you a series of questions down below. Expect about 4 to 5 questions somewhere in that range. Number 3, I'll give you a graph kind of like this. I just picked one out of your book. Hopefully it'll look a little bit better than this one. This one got a little faded for some reason. These 4, expect 4 or 5 questions somewhere in that range. Domain and range are a big thing. You have to put them in interval notation. X-intercepts, y-intercepts, maximum, minimums. Find the indicated values below the function if there's question marks that are down below it. That type of thing, that's something that you need to know and be able to handle. Number 4, graphing. This one is worth a lot of points because you have to graph the piecewise function. You have to kind of see where it goes. It's going to be 2 or 3 different things. I think you recognize this problem as problems. But then the idea was that once you have it drawn, then you have to answer a series of questions about it. The drawing is a super important question.
I don't have the back side.
Really? Does anyone else not have the back side of the first page?
Well,
Weird. Why did yours only one? That.
Yeah.
Weird. All right, just start with the front page. You don't need that. I think I just had enough copies. All right, whatever. All right, so number 4. Here's the thing I'm worried about. If you draw it wrong, you miss the questions down below it. So it's like important that you draw it correctly. That you know, like the starting point, kind of the direction it's going, if it has an arrow, if it has starting and stopping points, if they're open or closed, that type of thing. Because if you notice, like it's asking for range. That matters how you draw it. If there's any intervals where it's increasing or decreasing or staying flat, constant. If it has a max or min, like it really does matter if you draw it correctly. And you gotta know your definitions. So kind of know that. Number 5, you have to do a differential quotient. This one's huge, like this one takes a while. This one might be one of those problems you might have to put on like the back. Like, cause it does take a while when you set up that equation where you have to like simplify it down. Number 6, come up with the equation that is in point slope and slope intercept. Notice in the directions there's 2 different forms. You have to rearrange it. You have to do something very, very similar to that in this past homework, that page 188 stuff. Number 7, this is the parallel or perpendicular. Expect one or the other. I'm not joking. I randomly picked out the book, and I just put my finger down, and that was my pick. So it could be another perpendicular for the test, like no joke. There's no rhyme or reason to my madness on that one. I just picked one from the book because we didn't have homework on that stuff, so I just picked a random parallel or perpendicular problem. You'll have to graph it, and you have to give me the equation for it. So read the directions there. Asking in a certain form, so you do need to know your forms. I will provide you the forms on test day. They're going to be there for test day. Okay, questions on your problems. There's only 7. 7 problems.
Is that what they are on the test?
That's exactly what your test looks like that. I just picked a new picture, new number, something like that. That's all I did. So it has the same outline, same format, same directions, basically, because I just picked a very, very similar problem. So this is what test day should be. I'm not trying to pick like every problem known to man. I'm picking the ones that you should know that are very, very straightforward. There's a couple ones that are tricky in there, like especially number 5, takes a long time. My goal today is to go through problem number 3. That's it, 3 problems today, and then we'll do the other 4 tomorrow. Then test day is Wednesday. Does that make sense? Like, I want to give you time where you can actually look at this, look up stuff, see if you're doing it right. I don't want to overwhelm you and one day do it all and then test it next day. I'm not going to do that. I want you to be comfortable and you can ask questions and you can go through it. Okay? We're good to go. Let's start with number 1. Let's do it. Okay, let's go back to number 1. Bless you. All right. So we have to set up a table. Let's do that first. So setting up a table. This is one of those types of relations where you display data. Now, the x's are going to go over here, the y's are over here. Now, you have to go least to greatest for the x's. So what's my smallest x number up there? -3, then we have to go -2, then -1, 0, 1, 2, 3. Because again, I'm picking a problem out of the book that you did for this problem. This is the first section of chapter 1. I don't know what x numbers they're going to provide you. They'll just be kind of random numbers. It's whatever the problem gave you. I just retyped it. So I use the same directions that problem had, but it will be a graphing problem where they give you select x numbers, and you have to go graph those select ones. Whatever numbers they provide you, this is going to be a random set. Remember, it has to go least to greatest. Make sure of that. They have all numbers accounted for, and then you're going to plug these numbers in one at a time, and then simplify. Okay. All right. So on the first one, we plug in -3. What's 2 times -3? And subtract 4 more. -10. There you go. Now, if that coordinate is off the graph, no worries, just make up a dot where it goes, kind of roughly guesstimate. I try to give you enough space, you can kind of like guess where it's going to be. So -3, 10, that's the first coordinate. By the way, this is the coordinate we're going to be doing. -3, -10. So, -3 over -10. Oh, -10, sorry. -10. There you go. Boom. There's the first step. -3, -10. Next up, what do we get? Plug in -2, that's -4 minus 4 more. -8. Okay, so -2, -8. Boom. So -2, -8. Alright, so far so good. Pretty straightforward. -1. -1 times 2 is -2. We subtract 4. -6. I think you're starting to see the pattern here. And this is a linear problem, so you know there is a pattern, by the way. Why I know it's linear, like a straight line, is that there's no power in any of my variables, so it is a straight line. I can pretty much predict where the next couple are going to go. It's going to go, so this is -1, -6. Then it's going to go 0, -4, 1, -2, 2, 0, 3, 2. Like, it's just, that's what it's going to look like. It's pretty much guaranteed. So -4, -2, 0, 2. It's going up by 2s. I can already see that. Now, the only thing I'm hesitant to tell you about, like, once you recognize the pattern, if any of those numbers are missing, because I have no idea what numbers they're going to provide you. Like, you may not be able to just do that quick thing where you just kind of notice the pattern and go with it, because maybe I'm missing like these 2 numbers here. It's whatever the book gave you. So you might not need to plot these. So don't like think that the next one's going to automatically be -6. You have to kind of go where the numbers are. You might have to plug them in one at a time. Okay, I warn you, don't draw the line that connects them. The reason being, you're only drawing 7 coordinates. You're not drawing an infinite number of dots. Infinite numbers when you can draw the actual line. We're just drawing those 7 spots. I can already kind of tell where it's going, but that's it. That's all I need to see. Questions, comments about that problem? The graph will be provided to you just like that, so you can draw it, but you have to do your own table and go from there. Okay. I strongly recommend that you plug the numbers in one at a time just to make sure that you're doing it right. Type it in the calculator. There's 10 calculators in the back. If you need a calculator on test day, I recommend you bring one. There's more than 10 of you in here. I know that one person complains they can't have a calculator. You need to bring one. It's something that you should be expected to have. Okay, questions? Perfect, moving on to number 2. Okay, now let's explain this one. It's gonna be 4 or 5 questions, something like this, very, very similar. Basically what you need to expect is how to look at the table and then, you know, read off answers. And that's the part that some people just don't understand. They don't know how to look at this table and understand what it's telling you. Because, you know, we did a lot of these in the beginning of the chapter, but it's been a while, so it might be one of those things you just kind of forgot how to do it. So let's kind of walk through this. All right, what you're looking at is a table, just like I just did a little bit ago, but it's giving you 2 different function values. One of the formulas is y1, so these are the answers for y1 when you plug in these x's, and this is y2's function. It's a different formula, and that function, these are the answers that you have for it, for -3, -2, -1, 0, 1, 2, and 3, because these are the numbers you're plugging in. So these are 2 different formulas. The first question is to look at a certain formula, so y1, so we're looking at this column only. So these are the 2 that we're looking at now. Okay, y1, and you have to tell me the formula that represents it. So what I mean by that, you have to figure out which one of these 4, so it's basically circling A, B, C, or D, it's multiple choice, which one represents -3, 9, or -2, 6. So what I would do, personally, is just take each of these x numbers, plug them in, and see which formula gives you every single answer right there, and they have to be all the right answers. So anyone happen to know which one it's going to be? A, is that what we're saying? Okay, so -3. So when we plug this in, so -3 times -3, that is 9. -2 times -3 is 6. -1 times -3 is 3. 0 times -3 is 0. 1 times -3 is -3. Yeah, I agree with that. So letter A. So you just circle it. That's all you have to do. That formula is giving you all the right y numbers when you plug in all those x numbers. Does that make sense? There's going to be 2 that are going to be close. So just kind of make sure that you're checking each one so you're not accidentally making a mistake, because maybe the positive versus negative thing gets you. Okay? If it was asking for y2, like maybe it was asking for y2 here, then you're using this. You're using the x numbers and then these y numbers. That's how you read that. That's how I would do it. So if it was asking for y2's formula. Okay, do we feel a little more comfortable with the table, like how to read it? Okay, so now, let's keep going to the next question. So we have letter A. Number 2, does y1 pass through the origin? So that means, does it hit 0, 0 for y1? Did it actually pass through the origin? Yeah. 0, 0? Yes, it did. Because the coordinates right here, y1 did pass through the origin. Y2 did not. Think about that. It didn't cross the y. It didn't hit the 0, 0. Y2 actually had a y-intercept of 0, 2. So it had a different y-intercept. So y1, so this is a yes. You just put yes, that's a yes no question. Next one, at which points does y1 cross the x-axis? So for x-axis numbers, you have to have a number here. For x-intercepts, it's basically where it is across the x-axis. It has to have a number, comma, 0. So where did it hit the x-axis on y1? Number, comma, 0. Where does y1 hit the x-axis? 0. Yeah, hits right at the origin. We already said that earlier. Like it just had I don't care what this number is up here. It could be 0, it could be a negative number, it could be a decimal, but it had to have a 0 for the second number. It hit the origin, so the origin is an x-intercept still. So that's the idea, so 0, comma, 0. Now, if you just want to tell me, you know, the x number where it hit at 0, that's totally fine. If you want to give me the coordinate like 0, comma, 0, so you actually tell me like where exactly it hit, but that's an x-intercept. The y-intercept is when it has 0 for the y number, or I should say 0 for the x number, but a y number would be like that. That would be a y-intercept, or where it would have hit the y-intercept, y-axis. That would be that type of number. In this case, it would still be 0, 0. So just kind of, you need to know the definitions of like y-intercepts and x-intercepts, know like what the number should look like. Get rid of this red. All right. y1, y2, where do they cross? -1, 3. Okay, I agree with that. -1, 3. They have the same coordinate back here. So -1, comma, 3. And is there any others? It doesn't look like it. So -1, comma, 3. That's what I put. That's the one spot where they actually did cross. They might cross later, but I have no idea where that is. All right. Just what I would do, go in the book. I think this was the very first section of chapter 1 still. It was like problems 29 through 40. It was using a table. It was very similar to this one. This one I think is from my actual calculator, but I just took a screenshot of it, or took a photo of it with my phone. So expect something very, very similar tomorrow, or I should say Wednesday. Okay, we're good with 2. Last problem of the day. No joke. Last problem. Okay, number 3. We have to determine the function's domain, range, x-intercepts, y-intercepts. It has a min and max, that type of thing. You know, find the indicated values below the problem, below the question. This one always gets people, they don't know what they're looking at. This question is these. You have to find those answers. Those are the things indicated below the picture. Figure out the numbers. That was, I think, from section 2 or 3 that we had this problem from. Okay, now, domain and range, these are the ones that most people get wrong because they forget brackets, they forget parentheses, they forget all that little stuff. Okay, domain are all the x numbers. So what are all the x numbers I can use? Is there any breaks in my graph? No, it looks like it's flowing continuous. So it's going from negative infinity up to positive infinity. That's my domain. There's no breaks. If there was a break in the graph, maybe your picture looked like this. It went up, it stopped, it picked up again over here and kind of went this way. Maybe this is the problem that you have. Okay, fine. This is 1, 2, 3. Okay, so maybe the domain on like this problem would be bracket -3 up to -1 bracket. And the reason I'm using brackets is they're filled in circles. If they were an open circle, then you use a parenthesis. Or if it goes to infinity, you use a parenthesis. Union, so if there's a break in the graph, you use the union. Now we're starting at 0. Notice open circle, so parenthesis. And it goes up to positive infinity. Parenthesis. You're using x numbers. Do not be caught in that frame where you're using y numbers. I'm just looking at x's. So just be careful if there's a break in the graph, you have to use a union, go wherever it stops and starts again. Okay, questions. Okay, range. These are the y numbers. For range, again, just like domain, you have to go smallest to biggest numbers. That's why I start with the negative sign and work my way up. And negative infinity up to positive infinity, small to big. Same with the range, you go small to big. Okay? So what is my smallest y number that they're hitting? Negative infinity. Okay, good. So we're starting at negative infinity. Now we're going to go up and see if there's any breaks in the graph. And at the union, there's no breaks so far. What's the tallest number? 4. 4, and that's a bracket because it like went to 4 for sure. Now, if there was an open circle at 4, just put a parenthesis there at 4. If there's a union, maybe there's like breaks in the graph. Then you'd go there. Like if I was doing this problem, if you're doing like a range on this problem, even though there's a break in the graph, you start with the lowest point. Maybe this lowest point is -2. So the range would be from -2 up to positive infinity. Because, you know, I started at -2, it went up. I know there's still a break in the graph, but it covers everything here going up. So these are still covered, even though there's an open circle because this is filled in. And eventually this arrow keeps going up. So it started at -2 and went up to infinity. Like there wasn't actually a break because it actually overlapped each other. So it did cover every number starting at -2 and going up. Okay, questions with domain or range. Pretty straightforward. X-intercepts. Do we have any x-intercepts we're hitting? What numbers are we passing through?
-3 and 1.
-3 and 1? Okay. -3 and 1. I'm totally fine with you writing that. That is fine to me. Okay. If you write this, you just got it wrong. Why would I count that wrong?
Because it looks like a coordinate.
Yeah, you just told me a coordinate. -3 comma -3 comma 1 is not an x-intercept. So you got to be very, very, very careful. Put a plus, or maybe you just want to be safe and just write it like this: -3 comma 0 and 1 comma 0. Like that's fine. You want to write it that way. Just don't put a comma between the two numbers because that's an incorrect notation. Y-intercept, did I hit a Y-intercept anywhere? 3, okay. You can write 3, totally fine with that. You can write 0, 3. That's just what you have to write. You have to write whatever one is correct to you. Typically, problems only have one Y-intercept, usually. Unless it's like an oval or something, but I'm not going to pull something like that yet. So, okay, find the indicated values. Oh, does this thing have a max or min? Max, absolute maximum, right? It didn't go anywhere past that. So absolute maximum at what, 4? You could write that, or you could write -1, 4. That's the coordinate where the max is. I think that's roughly where it's at. So just be careful of that, because that could be a question in here. Now, the last problem, find the indicated values right here. These always get people. In fact, I'm going to zoom in on this just so you can see this. So these two answers, you're going to write down here. That's what they want for the last problem. So you have to look below the picture, because again, that's exactly how the book did it. I don't know why, but that's the way the book had it. So I'm just going to stick with the same format. Okay, so let me zoom in. Scroll over and up. Okay, so we're going to answer these bottom two questions. Okay, so we're finding where's the graph function value at -2. So at -2, this is an x number. It wants to know where's the y number at for this picture. So -2 is right here, that's the x number. And we're gonna go up and read off what is that y value right there. Maybe it's 3, or maybe you thought it was like 3.5. If you're in the ballpark, I'd pretty much give it to you. It's where you're kind of interpreting where it goes. But you have to be correct. Like if you told me it was -3, we have a problem. Or if you told me it was 20, we have a problem. Like you have to be in the ballpark. I would say it's about 3. That's what I would say. If you said 3.5, I don't give it to you. There's a little bit of wiggle room. It just depends on how you interpret that. Okay, does that make sense what you're doing on the first one? Second one, same thing. We're gonna figure out where 2 is. So you're figuring out x, this is the x number. I wanna figure out the y number at 2. So here's my x. Where is the y number down there? And it's not -4. -5. That's what I would say. -5. And again, you have to be.
Negative infinity, which is wrong.
Yes, that is wrong. It's the one number that you're going. I know it's heading towards negative infinity, but the actual value is -5 right there. So yeah, so just be careful. It was a really good question. All right. Questions at all about the first 3? Usually those go pretty straightforward. Those are pretty easy. Problem number 4, we're going to start tomorrow. I'm going to give you some time where you can actually work on this today if you want to like work through some problems. 4 is a tough one. Like it's tough. It gets a lot of people on my test for some reason. It's not meaning to be tricky. Just some people draw it wrong, so they get all the questions wrong. And number, was it 6? What's the one with that differential quotient? Is that 6 or 5? 5 gets a lot of people. No joke. Lots of people miss number 5 on my test. Because they don't understand like the setup. The setup's the hardest part of that problem. The simplifying is not hard. Okay, we're gonna go through those 2 tomorrow. We're gonna spend a lot of time on those tomorrow. Okay, you have the rest time is yours today. You can work on this. Tomorrow we'll do, what, 4 through 7, and then we're done. Okay, and test will be Wednesday this week. After Wednesday, so we'll take the test Wednesday. I'm hopefully gonna give you your test back Thursday so you can see your scores. And then you have 1 week to retake it if you choose to retake. Make sense? That way it's done before the quarter. If you're choosing not to retake it, that's fine, but your grade is gonna be set after pretty much this week. I said earlier, last week I even said this, Friday this week is the last day I'll take any late work, missing assignments, anything. Like the page 175, 188, if you haven't turned that in, maybe you're gone Friday, like that's due. I want all missing work, all fixes, everything's due by Friday this week. So you'll pretty much know your grade by tomorrow, because I mean there's nothing else to enter other than practice test and test. So just kind of be prepared. Practice guide, when is that due? Wednesday when we take tests. You have to hand that to me. If you're that person that loses this thing, just leave it here. I'll hand it back to you tomorrow. That way you're not misplacing it. Okay, because I only have enough, and I think I need to print the next one because I butchered leaders here. I didn't realize I need to go back to it. Okay, did everyone get the stapler? Did anyone need it? there you go. So camera here, and you guys can work on whatever you need to.